It's interesting. Like everybody's learning about containers and continuous delivery with containers right now, which I actually think will be interesting because a lot of times incidents come from, hey, let's just put everything in a container and see how that works out. So there'll probably be some interesting information here for everyone that maybe has a colleague over in the other session. So this is an awaiting Sev0 operational and incident consideration for architects. Did anyone see me last year present on this? No? Good. Okay, so it'll be all new. Great. Also, I'm sorry if I don't mean to, I could do this without the mic, but for the video, I'll keep the mic. So I'll have this loud, booming voice. I want to do a quick survey. So how many people here have that architecture job, software architecture job? 2, and then are the rest of you developers? Is that, yeah, developers? And who else? Program managers? The other couple people in the room? Yeah, program manager? Yeah? Cool. So how many people operate a software service that has had an incident or an outage? A couple people are not putting their hands up. I guess that means their software is perfect, which would be great, right? So how many people postmortem their outages? Yeah, cool. And then how many people consume the output of those postmortems? Yeah, okay, cool. I just like to level set on who's in the room. All right, so I want to start our session today with sort of a thought experiment. A lot of times DevOps is kind of a big thing, and so we talk a lot about DevOps. I did a presentation quite a number of years ago now, maybe 4 years ago, trying to look at sort of, if we look at all the other operational endeavors that humans are involved with and sort of look at the lessons that we could learn from them, what might we be able to apply to DevOps? And so I made this thesis or this argument that, you know, if we think of developers as pilots and operations people as air traffic controllers, what kind of interactions do we see in aviation that we might be able to sort of take from that realm? There's a link to the video at the bottom. I'm not going to go through that presentation, but I did want to start off with a thought experiment to kind of level set or have us think about today as we're going through all of this stuff. And so before I show you this video, this is a video, real life video of a controller and a pilot talking at JFK. I'm going to tell you, I'm going to ask you questions later, all right? So let's listen to that clip.
American 2 Heavy, ILS 22 left approach.
American 2 Heavy, Kennedy Tower, runway 22 left, you're number 2 for the field. Traffic's on a 4-mile final of 31 right. Wind is 320 at 22, clear to land, runway 22 left.
22 left, American 2 Heavy. Heavy visual for 22 left.
American 2 Heavy, 22 left, you're clear to land.
Clear to land. 22 left. Your localizer's not orange.
Okay, I will double check it. American 2 Heavy, they just reset it. Should be coming back up in a little while. Wind now 32023, gusting to 35.
Get 22. We can't land on 22. We're break out approach, and if you don't give us to runway 31 right, we're going to declare emergency.
All right, I'll pass it along. Fly runway heading for now.
Okay, we're declaring emergency. We're going to land 31 right. We're going to the left, and then we're coming around.
American 2 Heavy, just fly runway heading.
The area.
Okay, you're saying you're declaring emergency at 50?
3 times I've told you that. 3 times we're declaring an emergency.
Okay, I just want to verify. I know you told me if you didn't get 31 right, you would have to declare emergency. Okay, understand. Fly runway heading, and I got to get you a turn.
No, we can't.
JetBlue 62, the left on Alpha and monitor ground to the ramp.
That's Alpha, I'm on the ground. JetBlue 62.
I head in 180.
You don't have American 2 Heavy. We are turning around to the left here and landing on 3-1. Remove everybody from our way. We've declared an emergency.
Okay. So that sounds like a pretty stressful situation. If you fly into JFK, this is probably not what you want to be. You're probably glad that you're not hearing that back and forth. But I have a question for all of you to think about as part of the thought experiment. Was this event a success or a failure? So you might think, success or failure? And then the other question that I have for you is you might think, especially if you're an architect or involved in postmortems, what was the root cause of this back and forth and who was responsible for it? And so you might say to yourself, well, if somebody has to get in trouble, is it the controllers? Is it the pilots? You might even think of a number, it's 40% the pilot's fault or 20% the pilot's fault. So you might think about that as we talk about this and see if that answer changes at all. So this is the obligatory about me slide. I'm not going to go through it except for a couple things. I'm on Twitter, so if I say something here that is confusing or you want to talk about it more, you can tweet me. That's totally cool. The other thing that I will point out is I'm actually almost finishing up. We're actually going to talk about some of the research on this that I've been doing. My Master's of Science in Human Factors and System Safety. And the reason I mention that is because a lot of the stuff that we're going to be talking about actually comes from the safety sciences, and it's interesting to see that starting, I think in many ways, to permeate more and more into software. Are people familiar with the Therac 25 case? Very briefly, the Therac 25 was a cancer treatment machine made by a company in Canada, and I believe the Therac 22 had hardware interlocks, so it was a X-ray laser machine that would like burn cancer cells away. And the 22 was driven by software, but had hardware interlocks to stop the laser beam. The 25 was all software driven and had none of the hardware interlocks, and it killed 3 or 4 people and burned a bunch of other people. So this was back in the, I think 80s, late 80s, early 90s. So when you look at like the Uber accident where it just came out that Uber software in Arizona where the self-driving vehicle killed that woman, they found out that the software actually saw her, but its heuristic had been dialed up to not pay attention to her. So the car ran into her and killed her. So this idea of safety is, I think, coming up more and more in the work that we do. So we're going to be talking about a lot of these sort of topics today in the context of retrospectives and incident analysis. Blame, success, failure, human error is a big one. And as I was saying, a lot of it comes down to safety. Comes from sort of this idea of the safety sciences. And you might say, well, what does safety have to do with, I gave a couple of interesting examples about a classical one, the Therac 25 and Uber in the news. But you might say, well, what does that have to do with technology in general? What does this concept of safety have to do with technology in general? Has anyone heard of Knight Capital? Okay. Knight Capital was a high-frequency trading company that was, making a lot of money back probably about 4 years ago or so. And they did a deployment. They had a set of servers, and they did a deployment on a Wednesday to all of those servers, and then they opened up for Thursday on business, or for business on Thursday. And they started trading at 9 in the morning when the market opened, and they started noticing some weirdness in their trading systems. And it turns out that ultimately they ended up losing $145,000 a second for 45 minutes. So when they were done, the total was about $460 million. That was Thursday morning. They halted their trading systems 45 minutes into Thursday morning. On Friday, they were out of business because they couldn't cover their capital requirements. So when we talk a lot about safety, and by the way, when they sort of looked at this issue, they found that they had deployed the new version of the software to 7 of their 8 servers, so they had forgotten one, and that caused this problem. So we're living in an era where we can do a deployment on a Wednesday and potentially be out of business on a Friday. These systems can move so quickly. Now, you might say to yourself, well, that's cool, we're not doing high-frequency trading, so maybe it's not that important to me. I found this example recently about the PetNet pet feeder. And so it was this Wi-Fi connected pet feeder that you can buy, and then you can load it with food, and you can have a Wi-Fi mobile application on your phone, and it will, connect to the Wi-Fi, and then you can be at work and you can feed your cat or dog or whatever. And what was interesting is they actually had an outage, some minor difficulties with a third party. Anybody using cloud in here? Probably some cloud-based service that they were using that went down. But what was interesting is that the cloud-based service went down, and this caused their PetNet feeders to stop working. So they were starving people's pets for a day or two. Kind of an interesting, probably unintended and unexpected consequence. So we're going to go really quickly, not too in-depth, but I want to set the context for the history of how we thought about safety for a long time, and then I'll make sort of the leap to, okay, what does that mean for us in technology, and where's the connection there? Because they follow actually pretty interesting paths. These are all safety science researchers, Dr. Richard Cook, Sidney Decker, and at the bottom there's John Allspaw, if you've heard of him. He used to be a program chair for the Velocity Conference, which is a website operations and reliability conference. He also was the CTO of Etsy, and he's done a lot of research in this area as well. But he's mainly a technologist. He also wrote the web operations book. So when we talk about safety, like what humans thought about safety, going back to sort of the post-World War II era, we sort of modeled failure and safety as sort of a release of energy, an uncontrolled release of energy. And so that might be something like a plant exploding or something like that. And so we thought about the problem as, well, we can design safety in. And so if the lack of safety is just that uncontrolled release of energy, we can design safety in. And if you want more safety, what do? Well, you design in bigger barriers, right? Because there's a barrier between that energy that we want to keep contained and controlled and sort of that release of that energy. So this idea of defense in depth came up. And this worked relatively well, kind of especially in sort of the post-World War II factory era, where you could really go out and look at the factory floor and see things moving from station to station. There were machines working, and you could pretty much observe what was going on. This model worked relatively well in the ways that we think about it up until the late 70s. And then something happened in the late 70s. Any guesses on what that was? 3 Mile Island happened. Actually, 3 things happened. 3 Mile Island, Challenger, and Chernobyl were the big events that made us go, wait, maybe this is not the right way to think about it. Now, an interesting side note, if you know anything about nuclear power in the United States, nuclear power for, civil plants, they're basically submarine reactors that we bolted a generator onto, and then we made them really big, both of them really big. That's the basic technology. So there were 2 kind of takeaways that came up from 3 Mile Island. One of them is that you get emergent behavior when you scale a system like that. You can't design safety in because you get this behavior that you never thought of in the original design. So you can't really design around it or design to protect against it. That was one problem. The other problem is one of the major issues with 3 Mile Island is that there was no direct observability of the system. So I can't go into the reactor core and take the temperature or look at the pressure or what it might be because, of course, there's too much radiation that would kill me. So there's a bunch of systems in between us and the system that we're interested in that are monitoring systems. So we can't look at it, but we have to trust those systems. And what happens if those 2 systems disagree? And that's actually one of the big issues in 3 Mile Island. And it's interesting to think about, we're building a bunch of systems in the cloud where it's not like we can go to that machine or go to the cloud and look at it. We've got all these monitoring systems ourselves. So we're kind of running into the same problem where we don't have direct observability of a lot of the systems that we build. One other fun fact I'd like to point out about this, talking about the speed of these events. So some of you might remember those really old line printers, right? The dot matrix printers that had the green and white paper, right? So 3 Mile Island had a computer, and it had a printout of this that was supposed to be a record of events that happened. So when the meltdown started occurring, the printer, of course, started printing, and they let that printer go for about, I believe it's either 8 hours or 11 hours, but some number of hours before they decided to reboot the computer. because it was just still printing out stuff. When they went back and looked at the record, the printout had gotten through the first 4 minutes of the accident. So again, that's how much data was generated, that's how quickly events were moving before, at the beginning of that event. So we figured out that that doesn't work, this idea of barriers, and that's how we create safety, is bigger barriers. So there was a sociologist called Charles Perrow. He came up with this idea of that you actually can't be safe. We can't have safety because of this idea of normal accidents. And in his explanation of things, he said that his model was a degree of linearity versus complexity. So how linear is our processor system versus how complex it is? That's one axis. And then the other axis is how coupled is the system, right? So the idea is if I perturb the system over here and there's a component over here, will that perturbation propagate through the system? It reminds me of those little balls that you see on people's desks where you lift the ball up and it goes back and forth, right? So how coupled is the system? And his argument was certain systems, the complex, tightly coupled ones, will have accidents. And this is normal, hence the name normal accidents. But he also said this is also unavoidable. Like you can't, if you have those two properties, it's just going to happen. Now, I took this from his book because it's interesting to think about. There's some interesting examples on here. So there's loose to tightly coupling and linear to complex. So as an example of a loosely coupled linear system, he gives single goal agencies, so like the post office or the DMV, which is kind of an odd example. On tightly coupled linear systems, dams is the example he gives because dams are not a particularly complicated thing, but if if there's a crack in one part of the dam, the whole dam is going to go. Over here you've got things like universities, so loosely coupled, but it's a more complex situation. But really what's interesting is that he was talking about up in the upper right-hand corner there, nuclear power plants, nuclear weapons accidents. So again, tightly coupled systems, complex systems, not linear. So the last thing we're going to look at, and then I promise I will relate it back to technology, and on our own path through kind of this progression, which there's an interesting way that we sort of found this out, is this idea that a bunch of researchers actually at Berkeley said, hey, there's certain industries that we're not seeing the type of accident rates that we would expect, that Perrow says we should. They're complex, they're tightly coupled, and we just don't see the accidents. They called these high reliability organizations, and they studied a bunch of different areas. Power transmission was one of them. But the most interesting one is they studied the deck of aircraft carriers. And what they found is, again, very complex environment, relatively tightly coupled because you've got a lot going on and also not a lot of space to do it in. So they found out that those organizations, the reasons that they were successful is because they valued sort of constant active learning. So they, and to sort of facilitate this, they rotated their crews through. So they would do things where, there's a great quote from the research where one of the people on the deck of the ship says, well, we're on 6-week rotation, so as soon as I feel like I know what I should be doing, then I'm rotated to do something else. They do what's called decentralized active review. So this is the idea that when the person is working in the system, they can kind of look at the station to the left and the right and see if the picture looks right. And of course, to be able to do that, you need to know what that person does and what they're supposed to be doing on either side. So that goes back into sort of the crew rotation, this idea that, that you need to know how the entire ship works, or at least the deck of the aircraft carrier. Rank was de-emphasized, sort of oddly. We think of this as the military, so this seems kind of weird. But the idea being that the lowest ranked person on the deck of the aircraft carrier could say, we're not landing any more planes because we've got this situation, and that order was, or not order, but that sort of assertion held, and they would stop landing planes to figure out why that person said that. And then finally, this is probably the most interesting one, success may be failure. So that was the idea that the plane could come in and land, park, the pilot could get out, and every person in that system would say, that wasn't safe at all. We got really close to the edge there. And if you ask sort of the admiral or the captain or whatever, like they didn't bend a plane, they didn't bend the boat, and they didn't bend a pilot or anyone on the deck of the ship, but everyone would say, we didn't feel good about that. And they would treat it as failure. Okay, So back to technology. Why do we as technologists care about this stuff? Well, to review real quick, right, we have this idea, energy and barriers, normal accidents to high reliability organizations. And so the process you see is sort of static processes that are set when we design it, and repeated defenses, so multiple barriers, moving to sort of active defenses and processes. So the processes can change. The defense is that we think about and that we design in is sort of a living thing. We also see a shift from technical and engineering solutions to solutions inherent to people, the organization, and the way that we do our work. And that's actually the most interesting part, is that the solution is encoded in sort of the way humans operate that system. Now, I think there's something especially interesting here for people in the architecture role. Because, going back to the sort of emergent architecture or evolutionary architecture that Rebecca was talking about this morning, this is this idea that we would have a 5 or 10 year architecture plan, right? And we've moved to knowing that sort of doesn't work. Now, if you take this to sort of technology, and this is where I said I'd bring it back, if you've ever had to run a backup site or a disaster recovery site, right? That's the way we thought about the problem, is you'd have the site on the East Coast and the West Coast, and then there would be problems about mirroring the data and how quickly you could transfer over, but that's how we solved that problem, right? And then you see a shift similar to sort of this normal accident where, okay, if we could make the processes not as complex, or maybe not couple the systems so tightly together, we might have better outcomes. So this idea of simplifying things, if anybody ever wrote COM, right, we would write these COM objects that are fully tested and totally reusable, and that would solve a problem. Decomposing things into microservices, that's what that's about, right? Is that we can take the big monolith and break it up into smaller services that then hopefully are resilient or more resilient in their own right, then they won't pass failure along in between them. And what we're seeing now, though, is the organizations that are really good at operations, operating a service for customers or for the business. We see drilled incident response. That's what they're doing. Retrospectives, red teaming, and sort of this idea of value streams. Are people familiar with the term red teaming? Red teaming is where you hire a group of people to hack you constantly. Red team being the bad guys and gals, and blue team being the police or the protectors. Intuit, the tax people, have a really interesting story about, a number of interesting stories actually about their red team and how they basically hack Intuit all year long. So how do we go about architecting this idea of resilience, right, as we're moving from sort of the more static way of thinking things to the more dynamic way of thinking of things? Well, injecting failure. So who here has heard of Chaos Monkey? Everyone, yeah. So what's interesting is that Chaos Monkey is not, you would say this a couple years ago and people might not know about it. You say this 5 years ago, no one knew about it. And Netflix was doing this has been doing this for almost 10 years. Turns out I think they patented it in 2010, which is kind of interesting. But for those that don't know, right, Chaos Monkey is this idea, and there's different types of monkeys. There's Chaos Gorilla and Janitor Monkey, and so different Chaos Monkeys. But they go into your infrastructure, and in Netflix's case, it's Amazon, and they just kind of do random things, usually in the form of turning off nodes in Amazon, although they can do other things like induce a lot of latency in a particular node. That's sort of old hat. One of the interesting things that we see the industry starting to do now is chaos engineering. Anyone heard of that term? Yeah, a couple people. So that's the idea that we would get the entire team together, or some subset of the team, and actually engineer chaos. So it's part of sort of how do we do Chaos Monkey in production, but the other part of it is how do we get together to do a game day? Because you don't just want to say, hey, we're going to do chaos, and kind of go into the data center, start pulling cables out. And there's a lot of actual great talks. Tammy Butow from Gremlin, there's actually some companies doing this now that are working on how do you do chaos engineering, not only in a sustainable way, but in I wouldn't call it safe per se, but in a way that you limit blast radius if something goes wrong. One of the other things that you see as part of those exercises, and you saw people starting to do it before chaos engineering really had a term, is this idea of human chaos engineering. And there's a couple of interesting examples of that. So that's where somebody will go up to somebody and say, hey, okay, it's Thursday. I'm going to take your VPN key and your laptop and your cell phone for your work. We're going to take that. You're going to go home for a 4-day weekend, and then we're going to do an incident drill on Thursday afternoon or Friday. because they want to know who on that team has knowledge that nobody else has when they go to do an incident. So you're starting to see the social element. In the safety sciences, we actually call these systems socio-technical systems to get the social part. So that's kind of testing the social part. The other really interesting one that I've seen is they'll go up to someone who's using a Mac, who's a operations engineer. They will take their Mac and give them a Windows laptop, and then they'll run an incident. Because if you think about it, all of our SSH keys and credentials and VPN software and all of that are on our laptops. And if we're on call and the car gets broken into and our laptops get stolen, how are we going to deal with that? So they're finding out, because who knows, right? So incident command and crews. So that's the idea that we have a team that is responsible for remediating incidents, addressing incidents, that sort of thing. But also this idea of taking sort of incident command from firefighters. There's a lot of work done in the fire service and the forestry service about how they manage things, taking those ideas and making them a part of the work that we do. A couple of interesting things here. A lot of organizations say, oh, we're really good at incident response. And so I work with a lot of different organizations, and one of the things that I see as a pattern is, as an industry, we actually are getting better at incident response and sort of incident command command in the context of incident response. One of the things we're not as good as an industry is sort of dissolving the crew in a reasonable way. So what I mean by that is it would be like the fire department gets called, they roll up to the house, they get off the truck, they put the fire out, and then it would be like they all took their gear off, walked away, left the fire truck there. It's obviously not what they do. They roll the hoses back up, they get back in the truck, they back the truck back into the firehouse so that they're ready for the next incident. So as an industry, we're getting pretty good at the response. We're not getting so good at sort of wrapping up the response so that we're good for the next fire. We kind of drop it there when the incident's over. So one of my favorite topics is postmortems, or this idea of blameless postmortems. Who's heard the term blameless postmortem in the industry? Yeah, a couple hands go up. Does it feel weird? Does that term feel weird to you? How can we have a blameless postmortem? No? If it does, by the way, I won't blame you if it does. But if it does, there's a reason for that. So there's a researcher, sociologist again, actually I think at UT Austin, somewhere, one of the universities in Texas. Her name is Brené Brown. She's done a lot of work on this. And she has a great quote. University of Houston, I have it in my notes here. Her quote is, "Blame is a way to discharge pain and discomfort." And in the research she's done, she's found that sort of we're cognitively hardwired as a way to use blame as a way to sort of get rid of bad feelings. And we can even do that ourselves. We might blame ourselves for an incident. It's the same mechanism. So I always found sort of blameless, quote unquote blameless. If it feels weird, that's why it feels weird. And blameless it would be like us having a meeting where we go into the meeting and we're like, let's all pretend we don't have arms. I can see my arms and I can see your arms, but we'll just all pretend nobody has arms, right? It doesn't work really well. So if that concept's kind of interesting, there's a blog post that I wrote about that. You can read sort of some more thoughts on that. I think we're stuck with the term blameless, but if it seems weird, that's why it seems weird. So in the context of doing a retrospective, I think one of the things, and we'll talk more about this a little bit later as well from an architecture perspective, but one of the things that's really important is debriefing the actors. We sort of intermittently do this, I think, when we do incident postmortems in our industry. But it's important to debrief the actors and get their account of what happened. And of course, gathering the data, so hopefully you have your system instrumented in metrics together so that you can look at that stuff. And then of course, it's important to sort of create a timeline about what actually happened. And one of the things I want to point out, I've seen a lot of timelines in sort of my work with clients and stuff like that. And this is actually a really good timeline. The timelines that we do are seldom this good. And what's important to point out is that this timeline combines sort of that graph and metric data that you see with the tasks of what people are actually doing with what they were saying or what they were sort of eliciting as they were doing those things. And this becomes really important because when you start to sort of look at, well, okay, let's try to figure out what happened, you get these sort of vertical lines, these T1, T2, T3 lines. And those are sort of kind of events that we might call them, capital E events. And they're pivot points in the course of the incident that we would want to pay attention to. So for example, you'll notice, right, that somebody is doing a task and they stop here. And then there's the person saying, do you see that, right? So you can correlate, okay, was this related to this particular activity? You'll see some metrics that are high and then they start to go down. And of course, there's somebody else saying something about that. Somebody starts something as soon as those metrics start to go down. So if you want to get a really good understanding of what went on, it's really important to sort of have all of this data kind of one place. And lamentably, we don't do this very well, for a couple of reasons, which we'll talk about. So what I'm going to ask you to do, this is going to be simple for us, is to get a buddy. So pair up, and since we have 5 people, one group, there are only going to be 2 groups, so pick a group. If you want these 3 and those 2, let's do that. Go introduce yourself. Yes, you're going to have to talk to someone. Form the teams however you want, but there should be 2. One of 2 and one of 3. And then what I want you to do is there's going to need to be an A person and a B person. So decide who's the A person and who's the B person. And for you, there'll be 2 A's or 2 B's. It doesn't matter. Got it? Okay. The other thing that you're going to need, if you don't have, is paper. Do you have paper? If you don't, there's some in the back. And there's also a pen, so you'll need that as well. I'll just get pads for you. Perfect. Can you grab just the whole stack? Thank you. You'll only need 1 piece. So what I'd like you to do, and this is on your own, so don't talk to your partner yet, is I want you to create a timeline for that incident that we heard at the airport that started the presentation. Now, the A people and the B people, the difference there is I want the A people to go from the start of the event and do their timeline forward. And I want the B people to start at the end of the event, the last thing you remember, and tell it backwards. Okay? So we're going to take a couple minutes, not a long time. Just write down a timeline, the things you remember, sort of in order, or if you're on the B team, going backwards. So we'll take a couple minutes and do that. And again, this is on your own. We'll do this for about another minute. Okay, get the last few events on your timeline now, or data points on your timeline. Okay, so set those aside. We'll come back to them. Now, one of the other things that you need to sort of think about, and this is super important again from an architecture perspective, is what I like to call a retrospective ready infrastructure. And so this really is the idea of sort of the black box of our system, right? The flight data recorders. And it's important that when we think about architecting for sort of operational operations or operational ability, one of those ilities, right? That we want to cover sort of the infrastructure itself. So that would be like the plane, right? How much, what the engines were doing, how much fuel they had, that sort of thing. The environment, so how fast were they going? The altitude, what was the, what was the weather like, that sort of thing. And also the operational aspects. So those are the people, what the people were doing, the cockpit, voice recorder, that sort of thing. And the important kind of takeaway, the really important takeaway, is that modern sort of tools and design patterns account for this. They account for sort of the ability to look back in time and get at least some data to put together into this sort of three-dimensional timeline. The timeline that I picture that I showed you before, I would say most operational timelines for incidents that I've seen are super one-dimensional, maybe two-dimensional. So how can you do that? What are some of our black boxes? Have people heard of chat ops? Yeah? So chat ops is the idea that we would do everything in a chat room. We would look at our we would do deployments in a chat room. We would do incident response in a chat room. Everything is in a chat room. And it's kind of useful because if you do that, then obviously your timeline, you have a first level right there because it's all time-stamped and you have all of that data. The other interesting thing is if you have a rule that we can't do it unless we can do it via chat ops, then you have to automate it, right? And to be very clear, this is not something where somebody, like you chat to someone, hey, can you deploy the site, and they do it. You tell the automated bot to deploy the site. There's a great story, Mark Imbriaco, who has done a lot of talks in this space, used to work at GitHub, and he talks about how GitHub gets denial of service attacked like all the time. And so he talks about he was literally on call, getting on a plane, and the alert went off, and he was able to start the initial round of DDoS protection from his phone on the Slack app on his phone, and then also bring in somebody else since he was getting on the plane to take over for him. And that's because they invested heavily in sort of the chat ops mindset. Teammate is a tool. It's a terminal muxer tool that allows two people to look at the same terminal at once. So it kind of facilitates that sort of like if we're debugging an incident, you can do like kind of pilot, co-pilot, or kind of the nuclear silo, turn your key style of debugging where you want multiple eyes on something. Maybe if you're trying to debug a database and remediate that, and you want to make sure that a couple people are looking at it as they do that work. And then, of course, incident response and management tools. There are a lot of tools in this space, and I'm talking about like PagerDuty, VictorOps, that sort of OpsGenie, those sorts of tools that are actually building this into part of the service they offer. It's not just paging anymore or alerting. It's really actually giving you at least that first level of data analysis, and then trying to actually some of the areas those tools actually would bring you back into their tool to help you do the retrospective or the postmortem. If you're not familiar with chat ops, there's a great O'Reilly report on chat ops, and you can grab that. It's just search for O'Reilly chat ops, you'll find it. So I want to talk a little bit about anti-patterns and resilience. So these are sort of the hurdles if you try to go do this. Like, what are you likely to sort of run into, or what are going to be the issues that you might, the challenges you might face? So organizational incompatibility. What do I mean by this? Well, I just mean the idea that some organizations are going to have a lot of trouble with this. I mean, it's kind of interesting. I've given this presentation a lot, and people sort of, you'll see people kind of chuckle in the audience if they think this applies to them. Has anybody read this book, The No Asshole Rule? This is a professor at Stanford, a business professor. And he wrote a book about what he called the No Asshole Rule. And it's a quick read. It's like 250 pages. It's a good book. And he defines very narrowly what he means by asshole. The other funny thing is in the first, I think, 3 or 4 pages, he explains why he calls it the No Asshole Rule, not the no jerkhead rule or the no poo-poo face rule, because we all kind of intrinsically know what assholes are. When we hear that word, we have a sort of emotional reaction to it culturally, I think. In it, one of the things I'll mention, he talks about the total cost of asshole to your organization. So if you have an asshole in your organization that meets his 2 criteria for what that means, $160,000 a year is how much it costs you. Just kind of an interesting finding. But I really like this quote. The best single question for testing an organization's character is what happens when people make mistakes, which is actually an interesting sort of framing of that problem when we talk about success and failure. But immaterial of that discussion, what happens to you and your organization or your team members and colleagues when they quote-unquote make a mistake? So one of the other problems or sort of issues with this or hurdles that I see is only certain groups get to fail. So I see this a lot. The joke I always make is I was in release engineering for a really, really long time. QA, same thing. They face the same problem. It's like when we mess up a deployment or mess up the bits, then it's a huge, it's an error. But when developers error, they're called bugs, right? And so you'll see this sometimes in certain organizations where the developers get a pass for sort of failure, but other teams don't. Or it's not always the developers. Sometimes it's the DBAs or whatever. This is the Toyota production system. If you've heard of that and sort of how Toyota does their manufacturing. Kind of a riff on that is this idea that stopping the line is a privilege. So those errors point to what are called andon cords. And in the Toyota production system, anyone on the line can pull the andon cord and stop the line. And what happens is a manager will come over and talk to them and say, what help do you need? Why, how can I help you solve whatever the problem is that you're currently having? There's an interesting story where Toyota, it was a joint partnership between Toyota and GM. And it was a GM-owned and operated plant, but they brought in sort of Toyota management methodologies, and they included the andon cord on the line there. And this was a plant in California. And so they had American managers, and so one of the employees pulled the andon cord, and the manager came over and said, "Why did you pull the cord? Why would you do that?" Right? And so what's interesting is what did that manager teach that employee and every person who saw that interaction? Never pull the andon cord, exactly. Yeah. So that was sort of an interesting thing where it's like, if we talk a lot about continuous delivery pipelines and things like that. I think the biggest analogy here actually is certain organizations have a policy that certain people can turn the pipeline red and will deploy it anyway because there's something wrong with the pipeline, not the code they wrote. I've seen that a lot. It's like, yeah, it's red, but I'm sure it's fine, just merge it. That's kind of our version of that problem. Forgetting to dampen failure where possible. So, we talked about chaos days. One of the interesting statistics that was given is if you're going to plan a chaos day, the recommendation is 90 days out you start planning. Now, you might not think, what would I plan for 90 days? But when you actually put it together to do it in a safe way that is not going to blow up your entire organization or burn out your team or piss everybody off, it takes 90 days to plan. And that's based on that was a figure from Tammy Butow, who works with a lot of organizations. She's from Gremlin, to build and run and plan and run chaos days. Of course, when you run them, right, a lot of organizations have I've seen some really advanced organizations, they do weekly chaos days. And what's interesting is they do it, but groups can cry uncle. They can say, whoa, we're too deep in a situation that we can't handle. And the other teams will stop and then go help them, right? So it's not just we're doing a chaos day now, sorry, fix it. One of the other things I'll point out is that at Netflix, Chaos Monkey is opt-out. So it's on by default, which might seem kind of interesting. One of the things one of the engineers told me there, though, is that when you bring a new microservice online to run in the Netflix ecosystem, you actually can opt out of it, and they have provisions for doing that. Because the thinking is that if you're writing a new microservice, you might not know all of its little sharp edges and all the ways to operate it properly. So they don't want to have Chaos Monkey come along and just like make your life horrible. But after a certain amount of time, 3 months, 5 months, something like it's less than 6 months, then you're sort of automatically roped into doing Chaos Monkey. So they give you some time to shore up your service, but you are expected to. Some other big hurdles or pitfalls, sort of thinking about this. Only reviewing failure. A lot of times, one of the best ways to say this is nobody postmortems why the site is up. There's a little video about this. Let's see. So it's kind of interesting. This plane's coming in, and it looks kind of weird, but right at the end, kind of straightens out. So that's fine. It worked out okay. So we might push our systems a little further since that one worked out, and this one's a little squirrely there at the end, but it worked out. So that's fine. This pilot got themselves into a pretty precarious situation. You'll see on the left there, the wingtip actually scrapes, and now is not even on the runway anymore, but got out of the situation. So again, nobody died. Maybe that's okay. And then you've got this California sunny lined up on the runway, looks perfect, and that happens. Now, I doubt any of you want to be on any of those planes, but which one got the postmortem, or the retrospective? Yeah, the last one did. So it's interesting to think about that, why we don't ask why don't we postmortem why the site is up. It turns out, and it goes back to that high reliability organization thing, that you learn as much from studying the successes of your organization as you do the failures. One of the other hurdles is sort of forgetting about bias. Bias is sort of ingrained in the way that our brains work. Did anyone think to themselves when I played that clip for you at the beginning and I said, was this a success or a failure? Did anyone think to themselves, well, did the plane land or not? If you ask that question, I want to know if they landed to know whether it was a failure or a success. That's an example of outcome bias, right? So in other words, we judge the success or failure of a particular set of actions by the outcome, right? And this is particularly important when somebody in a system does the same thing that's always been successful, and then one time they fail and it's like that person made a mistake. And it's like, no, I just did what I did every time. That's outcome bias showing. This is often called hindsight bias, the ugly stepsister of outcome bias. And this is the bias of, with knowledge of the present, past decisions were clearly poor. And I always give the time machine example because it's the example of, again, you're doing the thing you've always done. And it's like as if you could get in a time machine, go back and talk to yourself and say, are you really sure you want to run that script? And you're going to say, of course, because failure seems very implausible at this point in my life. And you run it, and then it goes boom, right? So again, a lot of times we'll see sort of when we try to do the analysis here, this idea of hindsight bias. And it turns out that it's actually pretty easy to find out or spot hindsight bias because you'll hear questions like, why didn't you notice X? Why didn't you do Y? Why did you not talk to Z, right, in this context of an incident? Those are called counterfactual statements because we're literally talking about a reality that did not happen. So it's that example of like, I don't have a time machine, so I can't always tell you like why I didn't do the thing. In fact, some of the worst postmortems that I've ever seen in terms of where the interaction was really, really bad and everybody just left it feeling horrible, and it also went off the rails and started getting like finger pointing and name calling, was where they went down a counterfactual path. Why didn't you do X? Well, I didn't do X because your team doesn't do Y, and then it gets really messy really quickly. Correspondence bias, I will just read the definition. The tendency to place an undue emphasis on internal characteristics to explain someone else's behavior. So I like to call this the quintessential DevOps bias, right? So this idea of developers, I want change, and operations people, I want stability. And like literally the second they talk to each other or have to interact with each other, they turn into frowny faces, right? It's this idea of like, oh, those, the operations people are like, oh, those developers, they just keep wanting to ship garbage, right? And they're shipping garbage because they're developers, right, is the kind of reasoning. And of course, on the development side, the operations people, it's like, oh, those operations people, I have to use, CentOS 2 to run my website as opposed to something modern. And of course, they only want that because they're operations people. So the point that I actually want to make here is we are awash as humans in a sea of bias. I just went to Wikipedia and looked at the page on human bias. By the way, one of my favorite ones is the IKEA effect. Does anyone know what that is? That's the human bias that we will place more value on something that we built, even though there is a clearly superior alternative, but we didn't build it. So it's this idea of, there's a nice mahogany bookcase, but screw that because I have this crappy particle board thing from IKEA, but I spent like 4 hours, putting it together with those instructions that don't make sense with those people that don't look like humans. So I care more about that piece of furniture. The other one that I will bring up is the rhyme is reason effect. That's the bias that when whatever you say happens to rhyme, people will believe it more of the time. They've actually done studies that if there's rhyming or alliteration involved in a statement, people will tend to believe it more, which, by the way, is why political slogans tend to be alliterative or rhyme, like political campaign statements. So the point that I want to make here is bias is built into the way that our brains work. There's a funny clip here from WHYY's The Pulse that I'll have you listen to.
So what you'll hear is a sentence, a spoken sentence, that's been transformed by a computer to sound like gibberish. Any idea what they said?
No.
You can hear it one more time. Okay, now we'll hear the real sentence.
The Constitution Center is at the next stop.
Does it make sense that time?
Yeah, wait, was that the
It
same?
was the exact same sentence that you heard the first time.
No way.
It's the exact same sentence. Your brain is always using prior information to make sense of new information coming in. So once you know what the sentence is, when you go back and hear the distorted version, you can apply that information and it makes sense.
Isn't that crazy? The point, but the overarching point is that I want to make about bias is you can't get away from it. So don't think you can architect bias out of a process. The organizations that I see that are super successful at this, they, much like Blame, are aware of bias. And so they sort of help each other out when it's like, oh, I think that's a counterfactual. In fact, Etsy has a number of, they published a postmortem facilitation guide. And if you ever watch some of their postmortems, they'll even help people when they're talking about their own sort of mistakes, will also fall into bias. Like I should have recognized that, and they'll say, "Oh no, that's hindsight bias." It's kind of interesting to watch. Garbage in, garbage out. So we talked about incident response and how our industry is getting better at that. If your incident response is garbage, then your retrospective process is likely to produce garbage because there's not a good input to that. So if you're not feeling like you're particularly good at incident response, that's what I would focus on over retrospectives. And some of this, by the way, too, can be, again, back to that architecture thing that we're talking about. If the system wasn't traditionally architected for operability, then you can have problems with sort of interacting with it in a incident response context because it may not be clear what's actually going on inside the system, or it may be difficult. So one of the last big hurdles that I see, or second to last I think, is deprioritizing retrospectives and learning processes. And there are a few takeaways at the end of this, and we'll go through them obviously, but I think one of the biggest things from an architecture or even as a leader in your organization perspective is sort of to think about the importance of this. So how many people have had this situation where there's an incident on a Tuesday and it's pretty bad and we get the site restored, but we sort of duct tape and baling wire and it's fine. And we're like, okay, well we'll do the retrospective on Friday, right? So Friday rolls around and in the morning we come in and that duct tape breaks. So then the site is broken all day. And we spend all day really trying to more duct tape and more baling wire and chewing gum this time. And then of course it's Friday, and so we're not going to do the retrospective then. We're going to go to the bar to forget that we just had to deal with all of this. We'll say, oh, we'll do it on Monday. So then on Monday we go and we find out that Amy, who was the lead engineer who led the incident response, she's on vacation. She's on vacation for that whole week. We say, okay, well, we'll do it the week after when she gets back. We find out that Monday, there's an offsite all hands for the entire company. So we'll do it Wednesday. And then Wednesday, oh, that's sprint planning. Okay, we'll do it Friday. And so suddenly, we're doing this retrospective, 2, 3, 4 weeks out, right? So to sort of illustrate this point, what I would like you to do is get with your group, and I want you to compare your timelines that you did. So let's do that for a couple minutes. Just chat with your partners. We'll do this for about a couple more minutes. About another minute. So let's come back in a sec here. 10 seconds. Yeah? So here's my question. Did your timelines match? No. And here's the thing. This was 45 minutes ago, and I told you I was going to ask you about it. And yet, our timelines don't match, right? So when we go and do a retrospective to, 4 days, 5 days, a week, 2 weeks after the event, I guarantee you the thing that you're doing is your brain is taking the data, that doesn't age, but your brain is taking the data and filling it in what you don't remember, which you don't remember it, with bias. Just bias to make your story work. Did anyone find it annoying or difficult that this was aviation? And they're like, I'm not a pilot. How am I supposed to know what the timeline was? Yeah? Some hand go up? Okay. The reason that I do an aviation example is because we all have been on an airplane. We all generally understand you get into your seat, you get a snack, you take off, you land, you get to your place, right? That's how it works. But as we can see, there's a lot more going on, right? There's this idea of the way we might perceive a certain part of the system because of where we are in it versus the work that is actually happening in the trenches. And in so many cases, I see situations where somebody, especially maybe someone who has a senior power dynamic, comes in and they'll say, I know how the database works. You don't need to tell me how it works. I think the problem is with the database. But if you went and actually looked at what the database team was doing or what the engineers were doing in the incident, it doesn't match with sort of your perception of how it is, not because you don't know what's going on, but because of where you sit in the system. You just don't see the messy realities, they often are called, of work-doing people in complex systems. So that's why it's an aviation example. Last hurdle, landmine issue that makes this difficult to do, relying on human error or blame. This is another big thing as a leader in your organization or an architect that you can sort of influence, right? Do we describe problems by saying, oh, well, it was human error? Even if you don't blame them. Let's say you're like, we're blameless, cool, but it's human error, right? Anyone remember the S3 outage? It was about a year ago now, maybe 9 months, something like that. Big deal, millions of dollars lost. This is the postmortem for it, the public postmortem for it. I tweeted about it. The TLDR's engineer mistyped a command, took more servers out of rotation than they had intended to do, and millions of dollars of impact to AWS, and yet you won't read the word human error in their report once, which I think is actually pretty amazing. So Amazon sort of got a huge opportunity to learn from this incident, right? Among the things they learned is other operational tools with no input sanity checks, right? So there were other tools that just took arguments and didn't validate, hey, do you really want to pull all 800 servers out of rotation instead of 80, right? So they were able to look at all of their tools in their fleet that are for managing AWS itself and start to add some of those guardrails in. Of course, with force options if you actually intended to do that. If your goal was to actually take down AWS. The service health dashboard that you can look at AWS went down. Why? Because it relies on S3. Oops. They didn't know that, right? So they had to launch a new service health dashboard or an interim service health dashboard. The indexing system, subsystems insufficient partitioning due to growth. So this is the idea that the indexing system automatically rebalances itself. And it was based on an algorithm that they had designed a number of years ago, and it worked relatively well. But what caused one of the factors in this outage is that happened in US East 1, and the algorithm wasn't designed for the extra usage that US East 1 gets. And you might ask, why does US East 1 get so much extra usage? And it turns out on the dashboard up until a few months ago, US East 1 was just the first option. So when you're clicking through launching all your infrastructure, people would just not change that option. So the point is US East 1 had characteristics that none of their other availability zones had because of just people not changing the default option. So they changed that algorithm to account for that. And also, the indexing subsystem had not been fully restarted in years, which is interesting if you think about it. This subsystem had been handed off baton style and had not been rebooted. They had not taken it down and brought it back in, I think, 5 years. So it's like that old, like we have a server, you know, those old AIX or HPUX servers, right, that never get rebooted. It's like, I don't know that I want to reboot that Solaris box that's been running since Solaris 2.5. So had Amazon just called this human error, human, messy meat human made a mistake, and then maybe fired them, they wouldn't have ever learned about these critical details about their system, but more importantly, how they go about operating their system. So for the last bit of our time together today, I want to talk a little bit actually about sort of the research I'm doing and the findings there. So we're going to do a high level sort of the research, and then at the end are going to be sort of the interesting findings. I think if you do retrospectives, or if you think about what retrospectives are for, there's some really fascinating findings there. And then also there, we'll tie it all together with a bow with about 5 takeaways that you can look at when you're sort of thinking about architecting your systems or operating sort of these larger scale systems that are important. So I want to throw this slide up there. This is work that I've been doing at Lund University. It's in Sweden. John Alspaugh, I mentioned him before, I mentioned him again. He was the sort of first IT person to go through this particular program in human factor system safety, IT software operations person. My classmates, my colleagues in that program are, we have a couple doctors, we have a trauma surgeon, we have air traffic controllers, we have pilots, we have maritime insurance people. I think the most interesting one, we have a classmate who he works with the Danish military, I think, and they do live fire exercises, and if somebody gets killed, he goes in and runs the retrospective on that. So it's kind of interesting where I'm like, oh, I researched why the cat GIF website went down for 3 minutes, right? And they're like, well, someone's head got blown off, and that was the retrospective I had to run. It's kind of interesting. Interesting dichotomy. This was the research question: in industrial practice, in what ways and to what purpose are the artifacts produced in a post-incident review process utilized by a software development and operations company. What is this actually asking? Okay, what do we actually do? We run a retro, we write all this paperwork, we file all those JIRA tickets, we do all that stuff, and then what do we actually do with it? But no, for reals, what do we actually do with it? Because I've seen so many presentations where people are like, oh yeah, we do all this great stuff. And then I've been subsequently hired to work with them, and it's like, you don't do any of that stuff you said you do. Or you do, but it doesn't actually work for the reasons you think it works. Which there's an example sort of here. So to give you an idea, just kind of where the research is, operational retrospective, so that's road, nuclear, stuff like that, the people that I were talking about. Organizational learning, so that's like how do organizations learn, and then IT agile retrospectives. So the point is, if you look at the research literature, these are kind of the big areas, right? There's been research on IT and agile retrospectives, kind of sprint retrospective type stuff. And of course, if you fill sort of those overlaps in there, you get sort of this kind of sub-research areas. The one thing I would point out that I found very interesting, the only overlap in sort of IT and agile retrospectives and this idea of operational retrospectives that I could find is security. Security incidents have been researched, and I think that's because we think they're dangerous and there's actual, usually a monetary loss associated with that. Anyway, so this is sort of the combination of all of those things is sort of what I was looking at. Put another way, this is sort of a picture of what I was trying to study. And the main takeaway from this, we're going to talk about the sort of two phases here. But the main takeaway is the first phase was to sort of look at the documents and the artifacts themselves. I don't so much care about the incident, the outage, or what you did. I don't care what meetings you did or did not have. Doesn't matter. I was looking at sort of these artifacts, this paperwork. Okay. So this is phase one. This is what we're going to talk about. So we did an industry, or I did an industry survey to talk about this. I'm going to fly through this because I think it's interesting, but it's kind of hard to sit and look at graphs and get excited about that. One of the big things I will say, what do you think, I called it in the research post-incident analysis event. What do you think the most common name for it is? What do you think engineers in our industry call that thing? Root cause analysis. It's interesting, I didn't put that on the survey, but a bunch of people answered that as other, so that's a good guess. Any other guesses? The overwhelming winner was postmortem, almost 60%. Postmortem, retrospective, learning review, after action report, rapid improvement, other. I screwed up when I did this survey. I did not put root cause analysis. I should have. That's like half of the others is RCA. We'll talk a little bit about root cause because that's an interesting one. How many you hold a month? So I think this is just sort of interesting. Some people taking the survey don't hold any in a month, about 15%. And then you find, the majority, 2/3, a third hold about one a month, and then you've got another third holding somewhere from 2 to 4 a month, so almost once a week. I want to know about these people. Like, do they just like doing retros? So more than 8 a month, so that's more than 2 retros a week. Are their systems just constantly broken? Are they post-mortem little things? That might be an interesting sort of sub-project at some point. Last couple graphs on this. I don't believe this. It doesn't jive with my observations, but that's the difference between a survey and anecdotes. But 60% say they hold the retro 1 to 3 working days after the event, which is pretty good. And then finally, and this is probably what I think this will lead into the second part that we're going to talk about, phase 2, that I think is the most important. I know this is hard to read, so I'll read it for you, but or I'll point out the interesting things. But which of the following items do you create or record? So you have this meeting, and you write stuff down. What do you write down? By a large margin, 90% list of remediation items. So keep that in mind. What are we going to fix? Is 90% of people say they do that. Event timeline, that's also up there at 85%. You've got a bunch of other things, customer impact, technical analysis. The other thing that I will point out, individual narratives, way down here at 27%. So in other words, recording what individuals actually saw or did. Only about a quarter of people do that. We'll come back to see why that's important later. So some notable things about the survey. answering the question, which of the following items are created or recorded? Regulatory impact assessment. That's not one I would have thought of, but if you're in a regulated environment, I guess this organization looks at, for their next certification, what the impact of the incident is on their regulatory status. So that was new to me. Someone said this is extremely non-formal at my current place of employment, which sort of actually implies something interesting about the repeatability of the process. So 40% of people doing retros don't use a template, and 32% don't use a facilitator. So it's not super actually surprising to me that somebody would say, the thing we do when we have a retro is not formal. Like we kind of get in a room and talk about it, and then we write some stuff down, or maybe file some tickets, but we don't have a template or anything like that. This was also interesting. What items are created or recorded? Somebody wrote blame and fault. I don't know that I want to work at their place of employment. That seems like a sad state of affairs, but I guess that gets recorded somewhere. So, some interesting themes of that. Numerous surveys pointed out that there is no root cause. Or I should say, numerous templates pointed out there is no root cause. They said the language, there is no such thing as root cause, and then prompted people to use 5 whys, which, if you know the 5 whys technique, is a technique to get to root cause. So I thought that was kind of an odd dichotomy. A number of templates said they used the word luck. They asked people, where do we get lucky in the incident? Which, again, as engineers, maybe they're more operations focused, so luck is something that they would talk about. And by the way, I don't mean to say that's bad that they're asking. I think it's actually interesting that in their sort of framing of the problem, luck is a thing they would talk about. Numerous templates highlight and talk about preventing recurrence. So the point being, we're really interested in this idea of preventing recurrence. That's kind of what we care about. And one of the comments, I'm the only one with enough sense to think that this is important information, was a comment I got back. Someone, I guess, might be a little bitter. So kind of the findings real quick. Incident event templates serve different purposes, and therefore there are different types. So as part of that survey, I asked people, hey, if you can send me a template of yours, that would be great. The survey, the data you saw, the graphs, were about 300 people, and the templates data is based on about 25 templates. The 3 types of templates that I observed is type 1. This is a record of the event. This is what we think of. So if I were to go in any organization and say, hey, can I see your retrospective, and I didn't know anything about the way you do anything, I would probably assume it would be just a record of the event. It would have a summary and a timeline and some bugs and maybe some graphs, and it would look like a Wikipedia article almost. It would have headers that you filled in, and that's what it would look like. It might even be stored on a wiki page inside your company. Second type is facilitating the event. So that is basically all of the first type. In other words, they contain all the information of the first type, but encoded in them, either in a column on the side or embedded in them, is actually questions and hints to facilitate the event. So the focus is not just recording things, it's actually how to do the retro. They're really concerned that you are asking what the organization considers the right questions. Type 3 is the index card. There weren't many of these. There were only like 3. But they were so odd that I thought they were worthy of their own type. They remind me of, if you ever learned how to use a card catalog, right? They remind me of index cards in a card catalog. Their only purpose as a template and a report is to be able for you to look through them really quickly, find what you want, and it's all links to bug control systems and other documentation. So they're not deep, rich, they don't contain a lot of that information. They literally are, the other word I was going between index card and signpost. They're sort of signpost templates because they point you in the direction of where you would dig for more information if you wanted to know more about that particular incident. So that was, I think, had a number of sort of surprising results from the survey, but I wanted to go really deep in a case study with an organization and actually kind of understand how they do this. So this is, again, that methodology. The thing I would point out is the thing we're interested in. So actually, we're not paying attention to this anymore. We're paying attention to really the blue lines. So the question is, how do those people use those artifacts, and do they feed it all back into that black box that we've been talking about, sort of this idea of production? Do they use them that way at all? And how do they use them? Are there arrows on this that I should have drawn but didn't because we didn't know? So this organization that I studied, I guarantee you all know who they are. Unfortunately, due to research protocols, I actually can't tell you who they are, so I will refer to them as DevOps Co., just because it's easy that way. But some information on them. They are a business-to-consumer company, so they sell direct to consumers. They are available in multiple markets around the world, so they are worldwide. They're cloud native, so they run all of their stuff in the cloud. They're known for sort of stability and reliability. They have a lot of mind share around that. And if you've ever read the State of DevOps report, they would be considered sort of a high performer. What the State of DevOps report calls a high performer. So they do a lot of practices that we would expect. They do incident response via the familiar mechanisms. There are people on call. They spin up a Slack channel to do incident response or a bridge if they need to. They have a centralized group that coordinates this stuff, this incident management stuff. They do what they call sync meetings, though these aren't formal retrospectives. And this was interesting to me because they actually, over the course of an incident, might do multiple of what they call these sync meetings before they do a formal retrospective. And they may not do a formal retrospective at all. They may actually, the sync meetings may get them where they need to go in terms of organizationally what they think is important. And I thought that was interesting because it might be that they don't end up doing a final one because this is enough. As I mentioned, they call it an after incident review meeting, though they may not always do it. And increasingly less so. And that's because, I think it's the next bullet point. It's not, but I'll mention it. They're doing more self-service. So that centralized team that runs the incidents also used to run this process. They're pushing that responsibility of retrospectives down to the teams. So you see in DevOps this large thing about you build it, you run it, that sort of ethos. This is like you build it, you run it, you postmortem it, right? They're pushing that down. There's an interesting tension in remediation. So what I mean by that is they can come up with remediation items, and the team that develops and operates the service can say, yeah, that's a good item, we're not going to do it. And there's a tension between that central group that handles this and the team that operates and runs the service, where, again, the development team can just say no. But where the tension pulls back is if a team consistently says, yeah, we know we should do that, but we're just not going to do it, and they keep having outages, that's where that central team can actually tug them back and say, you know, you're having way more outages than the rest of the company, your team is, which has happened. And they'll work with them to either, you know, what can we do to help? Do you need more resources? Whatever it is, right? And they work with it that way. The other thing where they can sort of kind of call a veto on that is if a team had an outage and they're like, you need to fix that. And they're like, nah, we don't really want to fix it. And they can say, oh, we've had like 5 other teams around the company have that same problem, and you don't know that because you don't get to see all those outages, but we do. They'll say, actually, you need to prioritize that higher than you are. The last thing I'll say about the categorizing, filing, searching, and sorting of incidents, they have found that it's actually really difficult to do this in an automated fashion. And I recently saw a presentation where somebody was like, oh, we're going to throw all of our incidents into AI and have it work and blah, 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 blah. And one of the engineers here said, listen, if I have enough incident data to teach AI or big data, I have a different problem. Right? That's why it doesn't really work well for automated stuff. So the organizational artifacts that we looked at, I'm going to just go through these real quick because I talked about most of them. The most interesting one, though, that I will point out, so they have Jira tickets, tracking tickets. They have what they call a Q&A doc. That self-service was the thing I talked about before. They consider conference talks, both internal and external, as artifacts of incidents. And the example they gave is one team did a presentation, it was internal, on not the cause of an incident, but they went back and they looked at all the hazards present after an incident had occurred. So they weren't trying to figure out, what was the cause? They were just saying, when we show up to the fire, we notice, like we show up to the 5-alarm fire, we notice that they're all buildings that have gas or whatever, right? They were trying to identify things, not how the fire started, but what made the fire worse, in some sense. And then they made technology decisions based on that. So findings from this, different teams use the artifacts differently. So what I basically found is if you look at the operations and the security teams, they use it to refine their processes and to do trend analysis. Those things are really important to them. Development teams don't use them for that at all. They use it for architectural stuff and like driving architecture and also reminding themselves why they made an architectural decision. It turns out that a new manager was hired at a team and said, why did you build this way? This seems broken to me. And they were able to pull out an old retrospective from an incident and say, this is why we built it this way. And the manager was like, I'll stop pushing on you to change it the way I did it at my last company, which is an interesting way to keep institutional knowledge as opposed to change whatever architecture based on whoever gets hired from whatever company whenever they get hired. One of the really interesting things that I'll point out, they aren't generally used during incidents by those working the incidents. So what I mean by that is I asked everyone, like, during an incident, do you use these artifacts? And their answer to a T was no, but then later they would tell me how they did exactly that. So it's interesting that they don't sort of encode it that way. So one of the most interesting things is artifacts aren't the end game, they're a means to an end. And I think one of the biggest things is they use these artifacts to sort of refine the process of retrospectives themselves. There's a great quote here, it's kind of a strategic accountability more than tactical accountability. So it's this idea, I'm not gonna hold you to account for all of these various tickets, right? But I want you to do the right thing, that's strategic accountability. This one internal, this is actually the talk I was talking about, the hazards that had been present during all of our incidents. So it's a different kind of way of framing the problem. Artifacts reveal hotspots and distant but connected components of the system. So what I mean by that is they use the process to be able to sort of look through where are components on our system that are connected that we don't know about. And I'll actually show a graphic at the end here that helps with that. And probably most important, they're used to create and communicate context, tribal knowledge, and whatever we might call culture. So when an incident is happening and you're in the thick of it, things are still breaking, context can be really powerful. A developer said that. One of the interesting sort of sub-findings is that if you look, as the group inside the organization gets bigger, so we go from like team to the division of the company to like the entire company, the reliance on tribal knowledge goes down and the use of context, communicating what I need from you via context setting goes up in this organization. So this is that picture I want to talk about real briefly. Kind of if you take anything away from this talk, this is a good explanation if people are like, why would you do this? This seems dumb. Rasmussen is a researcher who recently died actually, at like the age of 90 something, but he made his name studying 3 Mile Island. He came up with this Rasmussen triangle. And the boundaries are a boundary of economic failure. So that's the idea that if we cross that boundary, it would be too expensive. We wouldn't do the project because it would be too expensive. Boundary of unacceptable workload, that's the idea that humans are lazy, so we are always trying to find ways to do work more efficiently, and workarounds and shortcuts and that sort of thing. And this is acceptable performance, acceptable risk. This is the boundary that you go over that boundary, then you have an accident or an incident. So basically, it's these 3 things. Now, pushing, he called these pressure gradients, pushing towards away from that, the economic boundary is cheaper, better, faster. So that's the business saying you need to do this cheaper, you need to do it better, you need to do it faster. You've got the workers in the system, the people doing the work saying maximum work for the least amount of effort, so they're pushing away from that boundary. Where are both of these people or groups in the system pushing the system toward? The accident boundary, right? So Rasmussen called this the discretionary space, and this idea that our system floats in this discretionary space. And his argument was that we need to get really good at exploring what he called the discretionary space. And bringing it back to what this organization that's highly thought of, what they do is they're trying to figure out these weird connections in the system that you wouldn't normally think of. They're trying to find where there's smoke and tiny fires. They see smoke. Is there a fire? Let's go investigate it, right? So that's what they're looking for when they do this. Now, this is from the SRE book, and I think it's important to bring up because they put monitoring at the bottom and then a sort of incident response, and then postmortem and root cause analysis are, but they're way low in the sort of service reliability hierarchy. So if you're an architect and you're looking at these things, it's interesting to consider that like development is like the second rung of this sort of Maslow's SRE hierarchy of needs. And again, this is right from the Google SRE book. You can find it lurking around in there. So these are the 5 takeaways I promised I would leave you with when you're sort of thinking about this problem. One last thing I say before we get to the takeaways. So if these seem weird to you, and you take them back to your organization, and your manager or whatever, your boss, whatever, says, this makes no sense, the Rasmussen triangle I found is a really actually great way to explain why those systems work the way they work. So takeaway 1, time, space, and sincerity is required. So what do I mean by that? Well, you need to hold your retrospectives in less than 72 hours. If you don't, they're just going to be garbage. You might as well not hold them at all. You can do something called multi-phase retros, which ask me about after if you're curious about it. It's a thing, and you can do it. But that's one solution for this. Invoking the space is really important. So teams that are really good at this, and also templates that prompt this, invoke the space. They get people in the right headspace to have a good retrospective or incident analysis. So that means being aware of blame, bias, those sorts of things. Make us do that activity very deliberately. Preparation matters. So if you hold a retrospective and everybody gets into the room and they start figuring things out there, that's a waste of everybody's time. All of the teams that are really good at this, they actually prepare a lot, it turns out, beforehand. So to make this practical, your design, implementation, and operations have to be retrospective ready. I talked about what that means, basically the black boxes. Your practices have to support this. If they don't, all of this is just gonna be a lot harder than it needs to be. And this, again, you'll find these takeaways are a mix of technical solutions that I think you can influence, but also as leaders in your organization, you can actually influence as well. Organizations gaining the most benefit don't do them for the reasons that we think they all do. So they aren't looking for a root cause. Root cause is not a thing that they talk about or think about at all. They're not actually about remediation items. In organizations that are top high performers, it's not about making a list of fixes and checking off the list. They actually don't do that. Even though from the survey data as an industry, we think that's the most important thing, which is kind of fascinating. It's not necessarily about convergence on a story. So this is the idea that you can have multiple perspectives on a system and you would see different things. So as you can see this is Prince Harry, I think, or whatever. And it looks like he's doing something. But if you look at the photo from a different angle, he's actually doing something else. So point being that your process needs to be able to account for different perspectives in the system. Takeaway number 4, there's one more after this. Blameless and blame-aware is table stakes these days. So if your organization is about finger-pointing and blameful, like you're not going to have a good time, which you probably know, but you probably shouldn't bother doing this. I'll tell one really interesting story quickly. I was working with a very large organization, again, one you would all know, and I had to deliver the message to their senior executives. The reason that you keep having incidents that you can't understand, I got hired because they were like, we're doing all of this stuff. Why do we keep having incidents? And the answer was, it's because your engineers are lying to you. They're literally lying in every report they write to you. And the reason they're lying to you is because you don't make it safe to fail. Their response was, I want the names of everybody who lied to you so I can fire them. And I said, case in point. I'm not going to go through all of this, or I'll go through it real quickly. But if you do this sort of blameful environment to blameless, blame aware, and then low investment. So how much time do we spend on this to high investment? This is obviously low investment and blameful is pathological. High investment and blameful, you see this a lot at enterprise problem management teams. In other words, they have a whole team that's dedicated to like looking into incidents and solving these problems. That's very expensive. It's incredibly expensive. It takes a lot of time, but if it's still blameful, because that whole process is I'm going to hold you accountable for solving the thing. So you see that in like enterprise problem management teams a lot. And then on the other side, if you've got, you're blameless but low investment, like you're not committed to the process of seeing the kind of incident management, why would you bother? And then of course you see the high performers are high investment and also sort of this idea of blame aware, blameless. And finally, sort of the most important one, I think, we all work in complex systems. It's interesting to me how many engineers are like, well, duh, obviously we do. And then they'll talk about things like root cause, or they'll talk about things about how they can directly and linearly control that system. It's like you just said it was a complex system. So the only thing that we directly control in a complex system and those environments is our reactions. We don't actually control the system itself. And our time is up. Yes, I was going to say, any questions?
One thought. So you mentioned blameless postmortem.
Mm-hmm.
Something that we can look at our organization, Retrospectives postmortem, which is not only after that service was down, I mean, what could I have done to handle that better in the past? So you kind of look at not only just even what happened, but how could you react to that in a better way? So that way you improve your system and not just all the way down. So I'm gonna lead because they're at fault. They have all the responsible items. I've got to think about how my system could behave properly.
Yeah, so with the really high-performing organizations, what you see them doing is trying really hard. That is what I would consider, or what I called in the research, tribal knowledge. It's really hard to try to pass that tribal knowledge with high fidelity to another tribe. Because if you think about it, what happens? The other team will say, well, that doesn't apply to us, or they don't know our system, or whatever, right? This organization spent, their centralized team spent a lot of time, like, how do we make it really easy, but also like, not eye-catching, but convincing that this is a retrospective report you should read and believe it, right? And they've struggled a lot with that. They've gotten good at it now, but it wasn't always that way. It took them a good 3 years to get there. And also a team dedicated to doing just that.
So a couple of the things towards the end of the presentation, you talked about postmortems not being about root cause analysis.
Yes.
And that problem management kind of not being in the ideal quadrant.
Yes.
Those things are part of the common ITIL process.
Yes.
Around service management.
Mm-hmm.
Are you intentionally detracting from that?
So I have never had anyone point that out. So thank you for pointing that out. Or the question was, so just repeat it for the video. The question was the problem management and the sort of area where you have big teams doing that, where there's a lot of investment but maybe blameful, is a part of ITIL. And so did I mean to detract against ITIL? And the answer is not consciously. There's a couple of things I would say. I am friends with one of the people who used to work at the people that own ITIL. And so we've had many conversations over coffee and scotch about ITIL, and he's a great guy. His name's Kaimar. There's two things I'd say about ITIL. ITIL has a really, really bad reputation. And I would say that I don't necessarily agree or disagree, it just has a bad reputation. And I think it has that reputation for the way that it is implemented. And so if you make that connection, I think other people would too, and I think it's because of ITIL's reputation. That said, you look at a lot of practices in DevOps and some of these kind of emerging things. DevOps isn't really emergent anymore, but it's like that we were doing that with ITIL. What is this, right? So it's not that ITIL is bad. What I was trying to say there is that I've worked with a lot of enterprises on teams that have problem management groups, and their sole reason for existing is to, in effect, point fingers and hold people accountable. And the problem with that is that is, in a sense, blame. It lacks the context of what the business may be asking those teams to do in lieu of maybe fixing every single problem. So on its face, structurally, it sets up that dynamic of why aren't you done with this? You can almost see it in your head if you have one of those things, like, why aren't you doing this, right? And I've worked with a lot of those teams to actually get them to a better place. So it doesn't have to be like that. I was sort of maybe stereotyping, and thank you for calling me on it, that a lot of just large enterprise service teams, their whole mandate is to basically blame and hold people accountable, and that's very expensive, right? So the point that I would make is it doesn't have to be that way. You actually can have that move to the ideal state. And I've worked with some problem management, VPs, that's their team, to get to a better place. But no, I'm glad you pointed out that connection to ITIL. I didn't consciously make it, but I agree with you. So, cool. Well, I think our time's up. I think it's almost time for the, oh yeah. Oh, yes. Yeah, the plane did land. People always ask, like, oh, OMG, what happened? And they landed, and they turned off the runway, and then I think they maybe had a phone call later between the tower and them. But JFK, if you've ever listened, if you find that interesting, liveatc.net has JFK tower on it. Just listen to it sometimes. You don't need to understand what's going on. You can hear it in the tone of their voices, how stressed they are, right? Because we're all humans. We can tell when people are stressed just by their voice. So if you find it interesting, JFK is known for being kind of stressy, though. Anyway, let's go grab a beer at the event or whatever. Thanks.